We have a piece of magnesium ribbon, and we're going to ignite it in the presence of oxygen in the air. A white powdery substance was produced.
Okay, hi everyone. What I'm going to do today is a simple hydrogen pop test. I'm going to use a magnesium strip, and I'm also going to use 1 molar of hydrochloric acid. This is going to create a acid-metal reaction. It's going to release hydrogen gas, and it's also going to cause a product of water as well. So, what you need to do for this one is just place a magnesium strip in your test tube, squirt in some hydrochloric acid, just enough to cover it. You should probably undo the lid first, enough to cover it, and then you place the stopper on top. While you're doing that, get someone in your group to light a match. I've got one pre-lit, and then you just have to wait for the fun to begin. It's going to be a little warm, so feel it, and then just wait. You're going to start to feel some pressure at the top with the popper at the top, and it should pop off soon. And then when it does, put the match in the end. Ready? Maybe a little bit longer. This is that awkward bit where you have to wait around and be quiet. Let's try it. Ready?
Oh, you did it.
Cool. Okay, that's a hydrogen pop test. And cut.
The next process involves ammonium carbonate. Ammonium carbonate is a white, relatively crystalline solid. It also has an odour associated with it as well, a very strong odour. It smells like bathroom cleaning solution. I'm going to go ahead and put some of this white solid into a test tube, and you can see what it looks like. White crystalline solid. I'm going to put it in a pair of test tube tongs. It's going to look like this. I'm going to go ahead now and light the Bunsen burner. And I'm going to put this into the Bunsen burner flame. We'll see what happens to the white solid. I'm hearing a little bit of fizzing going on here. Now, as I'm looking at it, see if we can get a close-up of this. Take a look at the top of the test tube. You may notice some droplets of a clear, colourless liquid forming at the top of the test tube. That's an observation we can make about this process. I'm going to put this back into the flame for a little bit longer. You hear that fizzing again. Now what I'm going to do is I'm going to get some litmus paper. I'll put a little bit of water on it. I'm going to put this litmus paper above the tube, and we'll see what happens to it. Now take a look at the litmus paper. The top part is what the litmus paper looked like before, and now you can see what the litmus paper looks like at the bottom. Alright, so now I'm going to put this back into the flame. And I'm looking at this, and it looks like the solid that was at the bottom of the test tube has completely disappeared. Okay.
As you can see here, nothing much happens to begin with. But then, if you watch, it starts boiling really quite nicely. You can see the nice precipitate of copper, where we can take it out, and you can see there
Hello, at this station we will be combining copper chloride and sodium phosphate, and we are going to form a precipitate. Remember, a precipitate or precipitate is a solid product. So I'm going to start out with copper chloride. This is copper 2 chloride, beautiful blue solution. And to this we are going to add our sodium phosphate. Our two products are going to be sodium chloride, that will be in solution. And then our precipitate will be copper phosphate. So I'm going to do this up close. So we should see a solid form. See that chunky stuff on the top? That's our copper phosphate. So this is an example of a double replacement reaction. It's beautiful.
You can either use the little caps that are on here that have a red and black type of wire here. We can use this as an electrode, or we can use simple alligator clips. We can use a piece of pencil lead and use that as an electrode also. Okay, we have our glass petri dish here, and I'm going to start by just adding a little bit of water. Add a few drops of universal indicator. This is a good time for me to also talk to you about the safety precautions here, because really the only safety precautions we have to really worry about here are with the universal indicator. Universal indicator is an alcohol solution. You can see as I'm adding it to here, some of the ethyl alcohol is evaporating. That's pretty cool if you ask me. Safety for this. Ethyl alcohol is a flammable liquid. It's also toxic by ingestion and inhalation. Make sure there's no flames or hot surfaces anywhere around here when we're doing this demonstration. We also want to make sure that we have good ventilation in the lab and that we do not ingest this. So after we're done using this, it's going to go back into the storeroom. Next, I'm going to add just a small amount of sodium sulfate. I need some ions in here to help conduct the charge going back and forth. I'm going to bring my 9-volt battery. I have got 2 pieces of the pencil lead attached to the alligator clips, and I'm going to just put these into the petri dish, and let's just watch. The orange is an indication where it's a very acidic solution, probably a pH 4, so I am producing H+ ions on this end where the red is, and the black electrode is forming a base or hydroxide ions. We can kind of play with these a little bit and make kaleidoscopes in here. We can play in lab as long as it's done safely. The last part I want to show you is cleanup. And cleanup is very easy because I'm going to take these guys out. Beautiful colors, but if I mix all this up, guess what I'm going to come back to? My starting green color. I've created the same amount of hydrogen ions as I have hydroxide ions. I get back to a neutral solution. As promised, I want